Hello guys, welcome to my channel. I hope you have liked my previous video. My previous video was about the series expansion that is thoroughly based upon the theorem of Maclaurin series. To do or calculate any type of series or value of that function, we need to use the Maclaurin formulae. But whenever you are doing any maths in MCQ, then you don't have an extreme amount of time to expand the series or to do this type of math. In this video tutorial, I will show you an easy rule to calculate the resultant very easily. I hope you will find out that quite enjoyable, and if you haven't subscribed my channel yet, please do subscribe and click the bell icon for tuning with our channel. And I hope this channel will help you to learn a lot, and I think that's the motive of the channel. Okay, let's continue. So if we take maths, suppose I say limit of x tends to 0 1 minus e to the power 2x divided by ln 1 minus x. If you see that this math has come into the questions of BUET 14-15 batch. If you know that BUET is the top universities, engineering universities that you will ever find, and this was a question. And if you have to do this question, then what you will have to do? You will have to expand this and this in order to find a resultant. But it is thoroughly tiresome because BUET only gives you 3 minutes to calculate a single math. So if we try to expand it by Maclaurin series, I hope it will take much time than that, but we will find out a way where we can do this process in much smaller time, I guess. So let's find out in the casual way. Suppose I say that we will expand e to the power 2x. What will we find? That is 1 minus e to the power 1. If you don't have the knowledge of Maclaurin series, I will highly recommend you to watch the previous video tutorial about series expansion. I hope that will really help you. So we will take e to the power 2x, and if we expand it in Maclaurin series, then first of all that will be e to the power 0, that is 1. Then we will have 2x, then we will have 2x square by factorial 2 plus 2x cube by factorial 3, and so on. This will turn into an infinite series, I guess. Okay, in the lower end, if we use the Maclaurin series again, we will find out that ln 1 minus x will turn into this type of series, minus x minus half of x square minus 1 by 3 of x cube. I again highly recommend you not to memorize this, rather use the Maclaurin theorem to really go through the result by that. Okay, then we will find, if we do a slight calculation here, then we will find that we have in the upper hand 1 minus 1, then we will have minus 2x minus 4x square by factorial 2. I am not crossing them by any means because these things will be eliminated in the next process, I guess. Then you will have to say 8x cube by factorial 3 plus that is minus infinity. In the lower end we have minus x minus half of x square minus 1 by 3 into x cube minus infinity. So here x tends to 0. So in the first day, if we take x out, and in the first term of the lower integer, then if we take this first term x, then what we will have? Let's see, limit of x tends to 0. In the first term we take x common, then we will have to minus 2 minus 4x square by factorial 2 minus 8, that will not be square, that if we take x common, that will be x. Then we will have 8x square by factorial 3 minus infinity. In the lower end, if we have x common, then minus 1, then minus half into x. If we do calculate, if we again reassign by multiplying with x, then we will find the same value. x square minus dot infinity. We cross these two. As x tends to 0, that means it is not equal to 0. It is a smaller value that is approximately very near to 0. It is not 0. That's why we say f of a and limit of f x tends to a f of x is not equal. That we say sometimes it may equal, but it is not equal in all cases. Okay, then we cross it. Limit of x tends to 0 minus 2. If we take if we add and if we position 0 in every x's position, then we will find that if it is 0, then here it is 0. That means we will have to say minus 4 by factorial 2 into 0 minus 8 by then I will not have to write this one, minus 8 by factorial 3 into 0 minus dot. In the lower end we will have minus 1 minus half into 0 minus 1 by 3 into 0 minus dot. So in the upper hand we will have 2 minus 2, I'm sorry. In the lower end we will have minus 1, because all things will be eliminated by as we are denoting them, as we are multiplying them by 0. So we will have 2 here. That's the result. So how much time we have taken here by doing that? So we will use a short way for that. That is what? That is that if we take this limit of x tends to 0, 1 minus e to the power 2x ln 1 minus x. If we place 1 here, then we will have e to the power, if we place 0 here, then e to the power 0. Then 1 minus 1. In the upper hand we are getting 0. In the lower hand we are getting 0. I'm again telling you to listen this sentence carefully. If we have 0 by 0 or infinity by infinity form, then we can use L'Hospital rule or not. Just only remember these two motion. If we don't have these two conditions, then we cannot use the L'Hospital rule, I guess. So what we will do, as this function, as this whole statement really maintains the form of this, so we can use the L'Hospital rule. So what can we have? We need to differentiate the upper hand and the lower hand. So we need to differentiate the upper hand, lower hand. So we are differentiating it. ddx of 1, what is that? ddx of 1 is equal to 0, because it is a constant. ddx of c is equal to 0, because a constant never change according to any type of variable. So the differentiation of this, or the change rate of this, is equal to 0. Next, e to the power minus 2x. We know that ddx of e to the power minus 2x is equal, e to the power 2x is equal to what? E to the power, if we take 2x as y, then we will have e to the power y 2x into, again we differentiate y, ddx of y. What we have considered y? That we have considered y as 2x. Then we will have a 2 in front of that. Then we have 2 e to the power 2x. That's what we are getting. Next, if we differentiate this one, then we will have to find that ln x. ddx of ln x is equal 1 by x. So ddx of ln 1 minus x, what will happen? 1 minus x. And again we differentiate it, ddx of 1, then we will have 0. ddx of minus x, that means we have minus 1. So again, if we continue in this term, limit of x tends to 0, minus minus get crossed, then we will have 2 e to the power 2x into 1 minus x divided by 1, because we have crossed the minus sign here. So if we place our e to the 0, x tends to 0 here, then we will have to find 2 e to the power 2 into 0 into 1 minus 0 divided by 1. Then we will have to find 2. So here we had to do a whole series expansion, and then we can come into a result that is 2. And when, on the other hand, if we have 0 by 0, infinity by infinity, then we are having this resultant 2. So that is quite easy and it takes much more less time than that. Okay, I hope you do liked and enjoyed the video. I also think that this will really help you to continue for the admission test and other exams as well. Please do subscribe and like my YouTube channel and click the bell icon for tuning to the next video. Thank you.